Hello, I am Carrie-Ann Houdeshell, a soil scientist working for the CEAP-Grazing Lands component, a part of the outcomes team for the NRCS's Resource Inventory and Assessment Division. The work I am presenting today is a collaboration with the Soil and Plant Sciences Division of NRCS, as well as Stone Environmental Incorporated. I would like to thank my co-authors, Loretta Metz, the CEAP-Grazing Lands component leader, Jason Nemechek from SPSD, Steve Barker from Resource Management Systems LLC, and Warren Rich and Alan Hammersmith from Stone Environmental, all of whom were instrumental in the development of the web-based application that I'm going to showcase today. I'd like to start by giving a brief overview of the CEAP-Grazing Lands component, and then an introduction of the SSURGO-QT app, and then I will give a short demonstration of the application itself. CEAP-Grazing Lands is one of 5 components that is part of the Conservation Effects Assessment Project within NRCS's Resource Inventory and Assessment Division. Our role in CEAP is to quantify the environmental effects of conservation practices on pasture land, rangeland, and grazed forest land. We also seek to estimate the economic values of ecosystem services provided by managed grazing lands. We use the NRCS National Resources Inventory, NRI, grazing land on-site studies data as the basis for our assessment work. Scientific literature, data from Bureau of Land Management, U.S. Forest Service, and field studies from the Agricultural Research Service. And universities also underpin our determination of conservation practice effects. We work with other divisions and staffs in NRCS, such as SPSD and the Ecological Sciences Division, as well as USDA partners such as ARS, BLM, and the Forest Service. We work with university researchers to create tools for quantifying effects as mentioned above. The Soil Survey Geographic Database Query Tool, referred to as SSURGO-QT, is just one example of a tool created by our component. We created SSURGO-QT to help us capture patterns in soil and site characteristics across diverse grazing landscapes. Its role is to provide a spatial display of soil characteristics that ultimately translate into soil performance data, such as what is a given soil capable of producing, into potential soil interpretations, such as what should it be used for or what shouldn't it be used for. This information is extremely useful in the conservation planning process and development of tools such as ecological site descriptions that help support conservation planning. We use the most recent data from Soil Data Access, linking that tabular data with the correct vintage of gSSURGO spatial data to create an interactive map of soil attributes. The data behind SSURGO-QT will be updated annually after each SSURGO and gSSURGO refresh. Both the spatial and tabular data selected by the user and the app can be downloaded for use on their local computer. SSURGO-QT was envisioned for use by soil scientists, conservation planners, landowners, ecological site specialists, and others, predominantly to aid in conservation planning. As many of us are aware, various soil physical, chemical, and positional characteristics coalesce to create variable expressions of vegetation across the landscape. But before now, there was never a map interface that allowed a user to select different soil characteristics to see where they occur, and if patterns emerge that help us interpret soil data more efficiently and effectively. This app is unique in that it focuses on physical and chemical soil properties in order to find common ecological sites and/or soil components. So I'd like to walk you through a brief overview of the application. This is an example of the splash screen that you will see when you open the application. We just completed a 90-day review of the tool and we're making improvements both to the splash screen and choice lists. Note there's a link at the top for the user to reference the user guide. And we recommend this as it provides links and explanations of where soil data and terms were obtained. So after you've closed that opening splash screen, you will see a map of all the major land resource areas, MLRAs, that are recognized by NRCS. The rest of the filter will open up once the MLRA is selected as seen on the next screen. Keep in mind, the tool opens with MLRAs, but the scale of the data is mapping scale for the soil components. You will see the map drill down as you enter your criteria. So I'd like to walk you through a brief overview of the filters. Once you enter an MLRA, you will see on the map that the list of filters available opens up. There are 14 filter options, and some have sub-filters. You will also notice that your MLRA is highlighted and that the map zooms to your MLRA. From here, you can click on each filter criteria to query what data is important to you. Keep in mind, since this is the filter, each subsequent choice you make is dependent on what soils exist with all queried properties or characteristics. I will show you an example of what I mean on the next several slides. So when you click on the down arrow for a soil property or characteristic, a choice list for that property will open. In this example, for MLRA 65 in Nebraska, I chose soils with a typic ustic soil moisture regime. On the previous slide, you might have noticed there were 431,000 records for this MLRA. That is the number of major and minor components. By filtering for typic ustic soils, there are now only 118,272 records. Note that I also opened the legend using the circled icon on the upper right side of the screen. Major components are in red and minor in yellow. When there's a darker red polygon, this identifies a map unit polygon that has more than one major component with your criteria. And when it's orange, that map unit has both a major and minor component that meet your criteria. I want to point out here how the criteria you choose above in the filter affects the choices as you go further down the list. Note that the only choices for soil temperature in this MLRA are for mesic soils. If you had chosen another MLRA, for instance MLRA 41, you would have seen 3 temperature regimes in your choice list. At this point, I have filtered for all soils with any type of sandy surface texture, which also have 0 to 35% total fragments in the top horizon and are very deep. You will see that I only have 4,938 minor component records left on my map. I want to know more about basic chemistry of these soils, so I can scroll further down the filtered list to see the options for soil chemical properties. Keep in mind that you can make choices for every filter option, but you do not have to. I want to point out one other feature in the filters, the question marks, such as the one I just circled. If you open it up, if you click on it, it opens up to provide a definition for the soil property or characteristic you are looking for. If we continue through the filter list, I chose to look at the electrical conductivity of these soil components. I wanted to verify that all of these soils were non-saline. And based on the fact that my record number didn't change, I know all of these minor components were mapped as non-saline in the upper 50 centimeters of the soil profile. I can scroll all the way to the bottom of the filter to see which ecological sites were correlated in these polygons, as well as to find which soil components met my filter criteria. At any point, you can scroll all the way to the bottom of the filtered list to the ESD and soil components, even if you have not selected any other criteria previously. Based on the criteria I chose, you can see there are 4 ecological sites correlated to the 3 minor components with the above criteria. In version 2 of this application, the ecological site will be the default, and there will be a tab where you can click the ecological site description number. One last feature I want to point out about the application is that the user can export the data results from the filtering. I've circled that icon. The data will download as a ZIP file containing a shapefile the user can then add to ArcPro or ArcGIS Map, as well as tabular data from SSURGO. This presentation is just a sampling of what properties are available in the application, and this presentation is based on the filters and features in our beta version. Based on reviewers' comments, we will add additional filters and features that will be added when the application is released for NRCS and the public's use later in 2021. As soils data is refreshed annually by SPSD, the soils information will also be updated to SSURGO-QT. Several key features will be added based on requests from reviewers. We will add a user-defined area of interest, AOI, as well as additional soil properties and characteristics such as pH and CEC, as well as flooding and ponding frequency and duration. There will also be other base map and more layer options for the user to choose from. Thank you for your time and interest in the SSURGO-QT application developed by CEAP-Grazing Lands in cooperation with SPSD and Stone Environmental Incorporated. Thank you to Jason Nemechek for creating the SQL needed for data extraction, Steve Barker for his assistance in developing filter criteria and choice lists, Stone Environmental for creation of the web-based application, and Dave Hoover from the National Soil Survey Center for his support and review of the tool.